Hi YouTube, Tim Unkert here. In this video we're going to cover some problems dealing with logarithms. This is part of a quiz review for Algebra 2 students. So let's start with question 1. What is the base of a natural logarithm? So the way you can write a natural logarithm is with ln, and that stands for log base e. Okay, so the base is going to be e. And how do you denote a natural logarithm? That means how do you write a natural logarithm? So you write it with this ln here. Okay, let's keep going. What is the base of a logarithm when no base is written? In this case, so let's say we just had log of, let's say, x. That's the same as log base 10 of x. So my solution here is 10. Okay, let's go to the next problem. Solve for x. Log base 2 of x to the 8th power equals 32. So we can take this power here, 8, and we can multiply it by the log with a base 2 of x. That's a property we can use, a property of logarithms, and we can set that equal to 32. And what that allows us to do is divide both sides by 8. The 8's on this side cancel, and we get log base 2 of x equals 4. We now want to write this in exponential form, so I'm going to write it with the base first, so 2 to the 4th power equals x. 2 to the 4th power is 4 2's multiplied together, so 2 times 2 times 2 times 2, which equals 16. So one of the solutions is x equals 16. But this particular problem has two solutions. It also has x equals negative 16. The number can be negative here because this original exponent 8 is an even number. So when you raise a negative number to an even power, you get a positive output. You can't take the logarithm of a negative number, it's going to be undefined. But if you take it of a positive number, you're okay. So in this particular case, because again of the even exponent, we also get the negative solution. Okay, let's keep going. All right, this next one, we're going to solve for x. We have log of x to the 5th equals 30. So I'm going to take the exponent, 5, and multiply it by the log of x, and that equals 30. We're then going to divide both sides by 5, and we get the log of x equals 6. Now, if you remember from problem 2, what's the base of a log when no base is written? It's 10. So for the exponential form of this problem, we can write it as 10 to the 6th power equals x. So what is 10 to the 6th power? Well, that's a 1 with 6 zeros after it, so it's 1 million. Now in this particular problem, we can't have a negative solution because we're raising x to an odd power, and that would give us a negative output here, and we can't take the logarithm of a negative number. Okay, in problem 5, we're solving for x again. We have the natural log of x cubed equals 21. We're going to take the 3 here and write it as 3 times the natural log of x equals 21. We're then going to divide both sides by 3. 3's will cancel here. We'll get the natural log of x equals 21 divided by 3, which is 7. If you remember from problem 1, then the base of a natural logarithm is e. So in exponential form, I can write this as e to the 7th power equals x. Now I want to leave my answer as e to the 7th power. I could take the calculator and approximate that value, but e is an irrational number, meaning after the decimal point, it's non-terminating and non-repeating, and as far as we know, it goes on forever. So the calculator rounds it, right? So we'll just leave it as x equals e to the 7th power. And again, this is a odd exponent, so we don't have to worry about having a potential negative solution. Problem 6, we have log base 243 equals 20, or not equals, log base 243 of 27. We want to evaluate this. So we can say this equals a log. We'll do a change of base rule here. So a log with some base c of 27 over log of some base c of 243. So what do we want to pick for c? We want to pick a number that we can multiply by itself enough times to get both 27 and 243. Okay, so the number that works here is 3. So if I do log base 3 of 27 over log base 3 of 243, well, log base 3 of 27, we want to know how many 3's do we multiply together to get 27. So if we do 3 times 3 times 3, that's 1, 2, 3 3. So the top is 3 here. How many 3's do we multiply together to get 243? Well, if we take 27 and multiply by 3 again, that's 81. And times 3 again, that's 243. So that's 1, 2, 3, 4, 5 3's. So the bottom is 5. So our solution here is 3/5. Let's keep going. All right, problem 7. Simplify the natural log of e times x times y. We'll use the product rule to rewrite this as the natural log of e plus the natural log of x plus the natural log of y. The natural log of e is 1 because the base of the natural log is e. So e to the first power is 1, or e to the first power is e. That's why the natural log of e is 1. Okay, so we have 1. We don't know what x is, so we're going to leave that as the natural log of x. And we don't know what y is, so we'll leave this as plus the natural log of y. And there we go. That's our solution for that one. All right, in problem 8, we're going to evaluate the log with the base 3 of 1 over 81. When you have something like this, I encourage students to figure out how many 3's we'd multiply together to get 81. So let's do that. So we do 3 times 3 times 3 times 3. So that's 4 3's, or 3 to the 4th. 4 3's multiplied together is 3 to the 4th. And another way we can think about this is log base 3, or we could write this as log base 3 is 1 over 3 to the 4th power. And now what we're saying is 3 to what power equals 1 over 3 to the 4th power? Well, if you know about negative exponents, 3 to the negative 4th power equals 1 over 3 to the positive 4th power. So our solution to this problem is -4. Okay, next one. Evaluate the log of 1 over 10 to the 9th. So again, this is when you just have log, the base is 10. So we're saying 10 to what power equals 1 over 10 to the 9th. So again, I'm going to have a negative power here. So I'm going to say 10 to the negative 9th power equals 1 over 10 to the 9th power. So my solution here is -9. Okay, one more. All right, simplify log of xy over 10. So we're going to use quotient and product rules here. So we're going to say log xy. We're going to rewrite this with the quotient, breaking it apart into log of xy minus log of 10. We can further break log xy, or x times y, apart into log x plus log y. And then log 10 is, remember the base here is 10, so 10 to the first power is 10, so the log of 10 is just 1. So we have minus 1. And that's our solution for the last problem. Hopefully this video was helpful to you. If it was, please like and subscribe.